So we can also see the concave upward. Maybe helping to differentiate the downward and upward is also you can take the arrow. So when you have the curve like this, you can take the arrow up, and then you can definitely see that it's going up, so upwards. It may be easier that way. And this is downwards. So every time you have a curve, then the inside curve is having an arrow, and when the arrow is going up, then it means that the curve is concave upwards. Or if you feel like you use your hands like U and it's upward, and I think this should be okay too. Okay. Or in more complete graph, if we define the concave downwards and upwards, if you look on the way this graph, okay, we see that it's downwards, okay, and then it's going upwards, downwards, upwards. So if we take the arrow, if we want to identify, this is going down, right? And it's going up. It's going down, and it's going up. Now, you see at every point that is mentioned here, B, C, D, and maybe P, you will see that the concavity is changing, right? It's going downwards, and at some point here, your graph is suddenly going upwards. This point we call the inflection point. We call the inflection point. So first, maybe before inflection point, let me just write conclusion from the concavity. So if your f double prime x is positive on interval, then this will result f is concave upwards. And if the second derivative is negative, concave downwards. And now we have the point that is stated at B, C, D, and maybe B, okay? And on this graph, a point on a curve is changing. Maybe not. Is called, let's say, inflection point. And you can see that the inflection point is happening when the curve changes from CU to CD or CD to CU. Okay, I hope my description is clear. So every time you see any change in the curve, like it's downwards and it's changing to upwards, there will be a point in the middle part of this concave upwards and downwards, which is the point will be determining when is the curve is changing. So we call it the point here, B, C, D, and B is we call the inflection point. And it doesn't really need to be the second derivative need to be 0. Okay. For example, this point here, most of the point we have a 0, but in point B, we cannot derive this sharp point, right? So the first definition for the inflection point is when the curve is changing from the downwards upwards or upwards downwards. Okay. But if you find the second derivative is 0, for sure, if you check there is a change, then there will be an inflection point. So whenever you have second derivative equals 0, it doesn't mean that it's an inflection point. Okay. Okay. Now, the relations between the second derivative, okay, when we have second derivative, with the curve itself, okay, if we can write it down here. So suppose the second derivative is continue nearby some c, okay, some point c. And if the first derivative of c is 0 and the second derivative of c is greater than 0, then f has local minimum. Okay. So perhaps the word's not really convincing, but if you remember that if we have concave upwards and downwards, concave upwards is like this. And this is perfectly, the f double prime is positive. Okay. So that means when you have the first derivative 0 and you try the second derivative and you get it's actually positive, then you can actually conclude that this is a local minimum, directly local minimum. So you can use the second derivative to check the local minimum and maximum also. So you have choices when you are dealing with first derivative and second derivative. But if you'd like just to try this from this f prime and look on when f prime is positive, negative, that's also fine. Still okay, finding minimum, maximum. But then this is more practical and you will get definitely the results. And now if similarly if you have equals 0 and then you have f double prime c is less 0, then f has local max. So you will see this is concave downwards, which is the second derivative is negative. Now let me give you a functions just to illustrate how we can try to find maximum minimum values and then find concavity, find inflection point. Let's try from a simple functions. X cubed minus x squared. So probably questions find max and min values. Find concavity, which means finding when it's going to be upwards, downwards, and find the inflection point. Okay, and maybe later part, the second one, maybe sketching the curve, sketch the curve. So the goal for chapter 4, okay, see this is chapter 4. The goal of chapter 4 is actually, the result is you're supposed to be easily drawing the curve from the calculus part. So you know when the curve is increasing, decreasing, when it's maybe having a critical point, inflection point, how's the concavity. And maybe you suppose that there is some point that the functions cannot have any, maybe some discontinuity, maybe, or maybe some points that having the function is not differentiable. Probably that should be covered on the chapter 4. Okay, so that's the idea. So first, maybe before we find the max min values, or finding concavity or inflection point, the first thing you can do is probably finding the whether the functions is crossing the axis. Okay? So you can check when x is 0 or when y is 0. So that's first thing. So maybe we can check whether when the so maybe I will write. Maybe it's quite annoying. So we can write the functions like this, and maybe we can equal it to 0, and finding where does the functions crossing the axis. So we find that when x is 0 and when is x equal 1, the function becomes 0. So which means that these 2 points, the curve will be crossing these 2 points. This is help us to draw. And then the second part, then we can try to find the max minimum values. So perhaps we can try to just take the first derivative. I think because it's just a simple polynomials, we can just derive. Okay. And then maybe we can take the second derivative to help us look the functions more clearly. Okay. So we have to. So first, perhaps we start from the first derivative. And then let's take a look whether it has a critical point or not. So that's equaling to 0. Okay, so finding critical point. So here's the critical point. The second part is critical point. Is when the first derivative is equal 0. So we can try to write down the first derivative as that, equaling to 0. And we get that when x is 0, and when x is 2/3, it seems that it's our critical point. Okay. Usually to help to identify and to analyze, we can check the x and 0, x0 and x 2/3. So maybe 0 here and 2/3 here. We check all the points that can be put into here and check the signs. We can check whether it's positive or negative. I think if we take negative 1, negative 2, it will be a positive because it will be negative minus multiplied with negative, so it should be positive. And then take something between 0 and 2/3, maybe 1/3, then you can easily multiply with this. And I think it should be negative, right? It should be negative. And then of course this will be a positive if you check with 1 or 2, okay, or 3. So from here we can see that it's going up, going down, and going up. This is the slope. This is the slope. Remember, if we deal with the first derivative, we will deal with the slope. Okay? We will deal with the slope. So which means that the slope at this point, or critical point, the slope is 0. Okay? It's called by horizontal tangent, because the tangent is horizontal. Another way to look at, we can check 0 and 2/3. Try just substitute to the second derivative. Okay? And we will know whether it's max minimum. It's the same way. So as alternative, check x0. This is -2. 2 over 3. What will be 2 over 3? 2, 4. 4 minus 2 is 2. Which means that, remember, if this is negative, this will be downwards, and this will be upwards. Okay? So this is probably like a downwards, or we can say that this will be a max. This will be a min. Similar conclusions from what we have in checking the f prime. Okay. So you can just checking through second derivative or checking by line number like this is also okay. So you can choose. Okay, and then the concavity. If we check the concavity, we need to check whether if we take it equal to 0. So 6x minus 2 equals 0. If we have solved this and we have 1 over 3. Perhaps this 1 over 3 is our inflection point, but we still not sure. So just try to conclude this 1 over 3 and then check in some numbers from in between this 1 over 3. So maybe checking 0, we get negative. We check maybe 1, we get a positive, right? So this will be negative and positive. So because we observe that it's changed from concave downwards to concave upwards, then we say that x equal 1 over 3 is inflection point. And then you can also write down, maybe if you need to write the concavity, then we can write the concavity. Concave downwards. This is when x is less 1 over 3. Concave upwards. This is when x greater than 1 over 3. And then if you want to make it into a graph, then we can start by taking some numbers that we have encountered before. So maybe 0. Maybe take 1 here, because 0 and 1 is our cross sections, right? It's crossing our axis. And then maybe we take 1 over 3, and maybe taking 2 over 3. Okay. And it's supposed to be, it's going to have increasing around here, right? And it's going to go down here. But then at this 1 over 3, it's going to have another one here. But to make sure that our curve is correct, maybe you can check 2 over 3, finding what value is that. And maybe to make sure that is it going to be larger or maybe shorter. We can check f 2 over 3. What our functions is x cubed. So 2 over 3 cubed minus 2 over 3 squared. Seems that we have 8 over 2, 7, 4, 9. So it's supposed to be negative 4 over 27. So it's supposed to be around, it should be small, so maybe make it a little bit smaller. It doesn't need to be perfect, like it's equally proportional with our calculation. That's still okay. As long as we mention that which one is the increasing one, concave, downwards, upwards, as long as we mention that, then I think it's okay. And then if we check each point here, then supposed to be, this is the critical point. This is also critical point. And also this is inflection point. This is local max if you want to be more perfect. This is local min. Okay, and for the next curve, let me just give you a functions that you need to be, maybe you need to think more. Let's just give you 2x squared and x squared minus 1. And then the other one is x2 over 3. Particularly the second one here is there is some interesting phenomenon or some interesting graph. We look on this function. If you want, you can draw the graph using the GeoGebra or any graphing website for the graph, just to make sure that you see how the graph looks like in the real life. Okay. So this is for our next sessions. Next Friday, right? Because you have holiday, I think, from Friday to Tuesday, right? So next.
Friday is also holiday?
Huh?
Is it Friday also holiday?
Yeah, Friday holiday. From this Friday until Tuesday. Because I think for some school they shifted maybe some anniversary or NDSC and they shifted the holiday to this April. So you have a quite long holiday, okay? So I hope you can manage your life. So supposed to be, it's like time to relax a bit before the next section, which is I think related to midterm and other activities as well. So I think I will just stop here, okay? And this is just a function that you can think and try to take on. Maybe you can take on through the calculus part, or maybe you can check with the GeoGebra also. So see you next Friday.